All right, hello. This is our proposal for our data mining class. We are group 7. I am Peyton.
I'm Trisha.
I'm Calvin.
And I'm Gaurav.
And what we're doing is we're going to be looking into how we can use data mining to help out in some health sciences. So, our problem statement is being able to leverage data mining techniques to be able to detect food products that could pose potential health risks to consumers by being able to identify outliers based on any bad nutritional value and be able to locate their origin of production. The data source that we are going to be using for this is straight from the U.S. Department of Agriculture. We have our link right here if anybody would like to go in and see where we're getting our data from. So essentially, these are going to be having a good amount of spreadsheets that go into great detail about different types of food, where they're coming from, where they're going, um, the types of things that are being used for it, all that kind of stuff just to be able to help us out with seeing the bad stuff that's being used, that's being put into these products. But to talk a little bit more about what our hypothesis is specifically, I'll pass it over to Calvin.
Thank you. So, what we're planning to hypothesize for this project is that we're going to say food products that are sourced from specific geographical areas or from specific manufacturing facilities have a higher likelihood of containing nutritional values that deviate significantly from recommended consumption that can potentially pose health risk. Essentially, what we're saying here is that specific areas that produce food have a higher chance than other areas of producing unhealthy food that could cause health risks to the people who eat it. So now I'm going to pass on for our exploratory data analysis plan.
Yeah, so we're going to follow the KDD process, and the first thing we have to do is pre-process our data or clean our data. And all that's going to entail is selecting our attributes that are going to help display our hypothesis. We'll have to select the needed files and kind of just filter through what we'll need and what we won't need. So that'll be the first step of that.
And this comes the data transformation and warehousing. Here we'll be involving with the ETL process. It involves extracting data from different sources and transforming it into a suitable format for analysis, and then loading it into a warehouse. Like this steps ensures that we have clean and well structured data. Next comes normalization of the data. So it will be help us to reduce the redundancy and improve data integrity. And finally, we'll be involving with the checking data.
And next, we'll be looking into mining the data and going into pattern finding. And how me and Peyton are going to do this is we're going to use a clustering algorithm to cluster the specific areas that the USDA found that they purchased food from. We're going to use regression algorithms to find the outliers in nutrition, and then we're going to train models to go through the data and report back all of the nutrition results to us.
Then finally, me and Gaurav will then take what Peyton and Calvin had to have done in the last step, and we're going to cross-validate those found patterns based on our testing data set and training data set. So we're going to just be seeing how it does with the introduction of new data. We're also going to have to check for any overfitting, measure the accuracy and precision, perform our significant tests, so either a t-test or our chi-square test, depending on how we see our data at that time, and then finally produce our visualizations, and so that we can actually demonstrate the significance of our project.
And that'll lead to the very last part, the consolidating results. So this will be pretty much the last thing that we're going to end up doing. This is all just putting our findings into one specific location where we'll, as a group, evaluate what the data is telling us going into the last step of the KDD. And from there, we will present our findings. And here's our Gantt chart. We figured that each step, just put 2 people on each task, would give a way to not have any blocking issues. And it should lead us to being able to finish right on time. But that's about it. Thank you very much.